So today we will be seeing about doubly linked list. Doubly linked list is a linked data structure that has a node that has three fields. So for that we are declaring a node using user-defined data type or derived data type, which is structured. Within that, as I said, three fields. The first field will be the previous link or the memory address of the previous node. So we are declaring it as a pointer, and then we are declaring pointer next, which will be the memory address of the next node. Int data will be the data of that node, particular node. So struct node pointer head is the pointer address that points the current or the first node of a doubly linked list. So this is used for pointing a particular node in a linked list, which always will be the first node in the doubly linked list. So then we are declaring like 5 functions. So these functions will be used for doing certain operations in the doubly linked list. Insert at beginning, insert at last, delete at the beginning, delete at the last, and display the old doubly linked list. So we are doing this as a menu driven program. So we declare int choice, and when the choice is not equal to 0, the while loop continues. So we do this in the main menu. So this is the main menu. It's this one for insert in the beginning, 2 for insert at the last. So we are using this in the printf statement, and then using switch case we can correspond the particular choice into particular function. So if the user puts 1, it goes the switch case corresponds to the insert at beginning function, which will corresponds which will direct this switch case to this function, and this code will execute. Similarly, all these functions get executed. So let us look at how this works. So first there is insert at beginning function. So insert at beginning is inserting the node at the first. So the things that we should consider is whether the previous node is null and the previous node is null. That is the thing we should check. So we are allocating the memory size of the memory into a struct. This will be used to create a doubly linked list. And if p equals null, which means if the previous equals null, then it is overflow, which is if p equals null, then it overflows, which means if the last element or the last the last field of the address is null, then it means there is no element that can be added. So that case is overflow. If there is if the p is not null, then we can add the item. So we get the item from the user and we check for the head condition. Head is a pointer that points the first variable. If head equals null, which means the previous memory address of the head equals null, then we are converting this node's particular next address as null and the previous as null, and then we are adding the item, which means in this case the node that we are adding, the previous field will become null. which means this becomes the first field. In that last field, the next element will becomes null, and the head corresponds to P. So the head will be corresponding to the first node if there is a first node already, and the head will correspond to the node that we are adding. So that is what it is happening in this case. So if the head is not equals to null, and then we are checking for this condition, so we are just adding the item, we are just changing the previous equals null, and then we are changing the next equals to null. So this is the case when there is no element or there is no node. So this is the case where there is a node and we are adding the node before it. So this is to create a doubly linked list. So this is to create a doubly linked list at first. So this is to insert a doubly linked list at first when there is a nodes when there are nodes already present in the doubly linked list. So this is how insertion and beginning works. Let us now look into insertion in the last. So insertion in the last requires temporary variable, because we are checking from the first, and we are gonna check from the first, and we should be adding at the last. So we just need a temporary variable where we can store the address of the head. So then this is the address for that particular node that we are going to add. So we allocate a memory for that node, and then we are checking if whether the allocated memory is null. If the allocated memory is null, then the doubly linked list is overflow. If it is not, then we can add the element. So we are getting the item from the user, and then we are adding that item in the node, and we are checking for head equals null, which means if the previous is null, this means there is no element in the doubly linked list. So we can add just like that. So that is like we see in the previous case, we change the next equals null, the previous equals null, which means there are no nodes before and after, and then we are corresponding the head to P. If this is not the case, and there is a node already exists, or there are multiple nodes that already exist, we just store the head variable in the temp, and we just check for the next of head. So if the next of head is null, that is, this corresponds to the last element. So the last node next, the memory address of the last next node will be null. So this while loop checks for that condition, and if until this condition is satisfied, the temp equals temp next, which means it keeps checking for each element, and when this condition is satisfied, the node is added in that last position. After this node is added in the last position, the memory address of the node will be the previous memory for the previous node. So the head will be pointing the previous node of the node that we are currently adding, or the head will be the temporary this temporary will be pointing at the last element before we added this node. So after this node, like we are storing this P address in this temp next, and P of preview will be temp, obviously. So P of next will be null, because this is going to be the last node. So node is inserted at the last. So this is how inserting the node at last works. So now deleting the node at beginning. So deleting node at the beginning. So first we check for the condition whether the head equals null. If the head is equals null, then underflow. This means there is no element in the list. There are no nodes in the list. If it is not, then we check for the next. If there is a single element, we check for the next memory address. If it is null, then we just remove of the remove of that node, and we change it equals null. That's all. If it is not the case, there are multiple nodes, we just store the id into a temporary variable, and we are changing the id, and we are removing the id. So it is stored in the p, so p will be removed. So this is how deleting in the beginning works. So deletion at the last works. Let us now see how deletion in the last works. So deletion in the last also works like the same case. In this, we are checking for the condition. If id equals null, it is underscore, because there is no nodes in that particular doubly list. Then if else, we also check for that if there is only one element or not. We are checking for it, and we can delete as we did in the first case. If it is not, then we store the id in a temporary variable, and we run the code, and we run into a while loop until the last node reaches. So p of next not equals null. When p of next equals to null, that means the last node is reached. So we run until that, and if that is reached, we change the last node, the p of previous equals to the p of previous of next will be last. So we change it, and then we clear the last node. So the node is deleted. So this is how the deletion at the last works. Now we have covered all the operations in the doubly linked list. This is how a menu driven program works. And then we also have another function known as display. So this is for the displaying the values that we have already created. So the doubly linked list will have a collection of nodes, and the last node memory address will be null. So to print the doubly linked list, we have to run a while loop and print all the nodes until the memory address of this node comes to null. So that is what we are doing here. We are printing the values. So p is equal to 8. This corresponds to the first node of the doubly linked list, and until this p becomes null, the loop prints the data, and we are incrementing the memory. We are just moving to the next memory address of the node. So let us run the code right now. So let us run the code right now. It asks for 5 options. We are giving inserted beginning. So since we didn't add any node at the beginning, it asks us for a value. So I am giving this 5. So it asks for the choice. So we choose to display the value. So printing values 5. So this is what the answer that we got. So the insert in the beginning works. So let us now insert at the beginning, given already choice being added. So 4, potato choice 5. So the 4 is inserted at the beginning. So let us now check insertion at the last. So okay, the 8 is inserted at the last. So now we will delete at the beginning. So the 4 is deleted. So this code actually deletes at the beginning. Let us now delete at the last. So the 8 is deleted. the 8 is deleted, so it's at the last. Thanks for watching.